Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to be talking about proving that lines are parallel. Very important to be able to prove that lines are parallel. In this first figure here that we're going to examine, we've got all sorts of angles here. We've got this exterior angle, which is x. Okay, that's the exterior angle. Why is it exterior? Because within the triangle are the interior angles, okay? But this guy is outside, so hence it is the exterior angle. Now, hopefully you remember what adjacent means. Remember that adjacent means next to. So W is hence called the adjacent interior angle. The adjacent interior angle. And Y and Z are called the remote interior angles. They're called remote because they're far away from the exterior angle. It's kind of like when you're doing a search and it says, oh, it's in a remote location. That means it's not near the headquarters or it's not near your house. Remote means that it's a little bit far away. So the angle that is right next to the exterior again is the adjacent interior angle. And what do we know about these two angles? What kind of angle does that form? It's a straight angle and they're supplementary. Very good. Okay. So what about this? Who cares? This is actually awesome, especially in the SAT. You're going to see this a lot. Right off the bat, I can guarantee you for sure, guys, that angle X, the exterior angle, is greater than Y. It's also greater than Z. We already proved and know that X plus W, since they're supplementary, they will equal 180. But what's new here, okay, the actual exterior angle theorem states that the exterior angle is equal to the sum of the remote interior angles. X equals Y plus Z. This is very useful in the SAT. Why? Okay. Let's say they tell you that this is 100 and this is 30. Okay? And then they'll go like this, X and Y. And they'll say solve for Y. There's an easy way to do this and an easier way to do this. One way to do it is say, okay, 100 plus X has to be 180. So X is 80. Then 30 degrees plus 80 degrees equals 110. 180 minus 110 equals 70 degrees. Pretty simple, yes, I know. But with this theorem, we can do that in one step. Oh, I know that 30 plus Y has to equal 100. So that means Y equals 70 right off the bat. Okay? So very powerful tool here, very powerful theorem. And the exterior angle theorem, which I already stated, states that the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle and is equal to the sum of the two remote interior angles. So that exterior angle is greater than both the remote interior angles and is also equal to the sum of the remote interior angles. And that is the exterior angle theorem. Very, very important. Okay? So a lot of stuff going on here. You got to remember it. You got to understand it. Again, that exterior angle is greater than either of the remote interior angles, and that exterior angle is equal to the sum of the remote interior angles. Now, identifying parallel lines. The good news here, Remember when we learned about alternate interior angles and corresponding and alternate exterior and same side interior angles? Remember that, guys? Remember that we learned we learned that when naming them, if those angles were formed between parallel lines and that transversal cut parallel lines, remember that I said that not only are they alternate interior angles or corresponding or alternate exterior, but they're also congruent? Okay, well, that's what we're learning today. Now, the reason we're talking about converse, I don't know why the book went this way, but the converse proves that if these angle pairs are congruent, then the lines are parallel. Tomorrow's lesson, we're going to visit the original theorem, where if these lines are parallel, the angles are congruent. So you're really going to be understanding this, hopefully. You're going to be getting this 3 different forms, okay? So I'm going to tear through this because we kind of already have seen it and know it. And the converse of the alternate interior angle theorem states, if alternate interior angles are congruent, then the lines being cut by the transversal are parallel. What does that mean? In short terms, it means if you have alternate interior angles are congruent, then you have parallel lines. And in this particular case, if angle 2 is congruent to angle 1, then you have parallel lines. Remember that we're talking about the z here. Yeah, that's a backward z, but the alternate interior angles, if they're congruent, then you have parallel lines. So we're really learning nothing new here today. It's just a converse, okay? So if alternate interior angles are congruent, then the lines being cut by the transversal are parallel. Okay? Number 2, the converse of alternate exterior angles. Guess what? It's the same thing. If alternate exterior angles are congruent, then the lines being cut by the transversal are parallel. Short form, alt x angles are congruent, then parallel lines. What am I talking about? If angle 1 is congruent to angle 2, then line A is parallel to line B. So again, if alternate interior angles are congruent, then the lines being cut by the transversal are parallel. If alternate exterior angles are congruent, then the lines being cut by the transversal are parallel. And that's it for this page. Okay. Converse of corresponding angle theorem. If corresponding angles are congruent, then the lines being cut by the transversal are parallel. Short form, core angles congruent, then parallel lines. If angle 1 is congruent to angle 2 in this case, line A is parallel to line B. Remember that corresponding, we're looking at the F. So if the top side is congruent to the top side, or the underbelly is congruent to the underbelly of that F, then the lines being cut by that transversal are parallel. So if alternate interior angles are congruent, if alternate exterior angles are congruent, if corresponding angles are congruent, then the lines being cut by the transversal are parallel. Now, using the converse of the corresponding angle theorem, the following would also be true. If 2 coplanar lines, that means lines are on the same plane, are perpendicular to a third line, they are parallel. Think about the logic here, okay? If line A and B are perpendicular to C, then A and B have to be congruent. Why? Well, we've got a sideways F here, okay? So that's a right angle, that's a right angle. Those are corresponding angles. If corresponding angles are congruent, then the lines being cut by the transversal, in this case A and B, must be parallel. So it's almost the same as the converse of the corresponding angles theorem, except it is directly related to perpendicular lines. So if two or more lines are perpendicular to the same transversal, that means that all of those lines that are perpendicular to the transversal are also parallel. Does that make sense? That's it for that page too, right? Okay. Perfection. All right. Converse of same side interior angle theorem. Here we have it a little bit different. Here the same side interior angle, if the same side interior angles are supplementary, then the lines being cut by the transversal are parallel. Remember that same side interior angles, they're not congruent, rather they are supplementary. So if you have same side int angles, then you're going to have parallel lines. And they can only be same side interior angles if angle 1 plus angle 2 equals 180. If angle 1 and 2 are supplementary, these guys right here, if they're supplementary, then you know that line A has to be parallel to line B. So we've learned a lot of theorems here today, but they're all pretty easy. If alternate interior angles are congruent, the lines are parallel that are being cut by a transversal. If alternate exterior angles are congruent, the lines being cut by a transversal are parallel. If corresponding angles are congruent, the lines being cut by a transversal are congruent. If two lines are perpendicular to the third transversal, or to a third line, then the lines that are perpendicular to that transversal are parallel. If the same side interior angles are valid, that means that they're supplementary, then the lines being cut by the transversal are parallel. And similar to that, this is not alternate interior angles, guys. This is a new one for you. This is the converse of the exterior angles theorem. Not alternate exterior, but just exterior angles. Now you may be looking at that saying, go, Mr. Morrow, it's the F. No. This here's the underbelly. This is the top side. They're not congruent. These are supplementary. If the exterior angles are supplementary, then the lines being cut by the transversal are parallel. Okay? If exterior angles are supplementary, then the lines are parallel. So in this case, if angle 2 plus angle 1 equals 180, then line A is parallel to line B. Just so you can understand this just comes directly from the same side interior angles theorem. Let's say that this was 80 and this was 100. Doesn't that mean that now, because this is a straight angle, doesn't that mean that that's 100? And doesn't that mean that angle 2 now is 80? And isn't 80 plus 100 180 as well? So if the same side interior angles equal 180, or exterior angles, same side exterior angles are equal 180, then it is parallel. And you know what I should have said, this is a converse of the same side exterior angles because that can cause confusion and I don't want that. So if I have same side exterior angles, let's make that a little bit more defined. Yes, sir. No, it has nothing to do with corresponding angles. Corresponding angles are congruent and you have the F. What I just said was same side, which is the U or the C. If same side interior angles are supplementary, that means that these lines are parallel. If same side exterior angles are supplementary, then the lines being cut by a transversal are also parallel. Has nothing to do with corresponding. So same side interior and same side exterior, same concept. If the same side interior angles are supplementary, the lines being cut by a transversal are parallel. If the same side exterior angles are supplementary, then the lines being cut by a transversal are parallel. Okay? And that's it. Now let's get to it. Here I have that AB is perpendicular to BD, and I have that CD is also perpendicular to BD. I want to prove that AB is parallel to CD. I want to prove that this line is parallel to that line. Now, we could immediately say, whoa, isn't this corresponding? Yeah, we could immediately say, if corresponding angles are congruent, then converse of corresponding angle theorem, then the lines are parallel. But I'm going to show you why. I'm going to prove the proof. I'm going to prove the theorem here. On a test or a quiz, you don't have to do what we're doing, but I want to show you the logic behind it, the why. Okay? And of course, step one, AB is perpendicular to BD, given. So that's why we have a little 90 there. From there, we know that angle 1 is a right angle. That's definition of perpendicular lines. Step 3, we can use the second given. CD is also perpendicular to BD. So therefore, we have another little right angle there. And now we know that angle 2 is a right angle. Sorry, 3 was given. And 4, definition of perpendicular lines. Now if angle 1 and angle 2 are right angles, what do we know about right angles, guys? They're congruent. So angle 1 is congruent to angle 2. Right angle theorem. I'm sorry, no. Right angle congruency theorem. Right angles are congruent. And now we can prove that line AB is parallel to line CD because of if corresponding angles are congruent, then you have parallel lines. Now, in a quiz or a test, this could have been a three-step proof. You would have had the given, you would have had the given. Actually, no, it would have been 5. You would have had all of this. Actually, no, you still. Yeah, it would have been 3. Okay? Does this make sense? Are you sure? Okay. Good job, gentlemen. Okay. Let us continue. First off, because this chapter is all about polygons, so I'm going to have to give you some information before we can prove things. And I want you to realize that for example 2, I'm giving you a definition here of a parallelogram. And a parallelogram is a 4-sided figure with both pairs of opposite sides parallel. That is a parallelogram. When you have a 4-sided figure and opposite sides are parallel, it's kind of like the tick marks. Okay? One little arrow, that's parallel to that. Two arrows, that's parallel to that. Okay? When you have opposite sides of a four-sided figure parallel to each other, then that is a parallelogram. I want to prove that PQRS is a parallelogram. And I give you that angle 1 is congruent to angle 2, and that angle PQR is congruent to angle RSP. So, let's get to it. Angle 1 is congruent to angle 2, that's given. So, don't forget, I'm not going to get lazy. Angle 1 is congruent to angle 2. Number 2, PQ now is parallel to RS. Why? How? Sir? Very good. The converse of alternate interior angles. So you could write this two ways. You could say alt int angles congruent, then parallel lines, or I will accept converse of alt int angles. Whatever you want, okay? I will accept either or. I will accept either or. So now I know these guys are parallel. So okay, we got halfway. We know that one pair of opposite sides are parallel. Next, I know that angle PQR is congruent to angle RSP. That's a given, right? So if angle PQR is congruent to RSP, let's look at that in blue, that means that this is congruent to that. What do we know about angle 3 and 4? Yes, sir. Why? Excellent, son. Excellent. Angle 3 and A is congruent to angle 4 because of subtraction property. Now, check it out, boys. I would use a colored pencil with my proofs from here on out because it's going to help you. Look at what I just created here. What shape did I do in blue there? A Z. So what do we know about QR and PS now at this point? That they have to be parallel. QR and PS have to be parallel. Why? Not alternate interior, but converse, right. So one of two ways. You can either go the long way and say, if alternate interior angles are congruent, then the lines are parallel, or I will accept converse of alt int angles. I will accept either or. And now that we proved that QR is parallel to PS, guess what, baby? PQRS is a parallelogram because of the definition of parallelogram. If you have a four-sided figure where the opposite sides are parallel, well then giddy up. You have a parallelogram. Does that make sense, boys? Gentlemen. All right. Good stuff. Good job there on the subtraction property. I'm proud of you. Okay, last but not least. A trapezoid, gentlemen, is a four-sided figure with exactly one pair of parallel sides. They tell you that angle 1 is supplementary to angle 3. Angle 2 is congruent to angle 3. And I want to prove that TRAP, trap, is a trapezoid. So I want to prove that this guy right here is a trapezoid. To prove that, I need to prove that RA is parallel to TP because that is a trapezoid by definition. Yes, sir. You wanted to start it? Okay, let's start it. What would I do first, my brother? Of course. Angle 1 is supplementary to angle 3. That's given. So I can't really mark that, except I know that angle 1 plus angle 3 is 180 degrees. Awesome. Next is, I can't go anywhere from that, so next would be my next given. Angle 2 is congruent to angle 3. Okay. Well, if angle 2 is congruent to angle 3, and angle 1 is supplementary to angle 3, what do I know about angle 1 and angle 2? One is supplementary to angle, well, um, wait. One, no, 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 no. Yeah, that would be substitution. Yeah, yeah. Actually, yeah, 2 is supplementary to 3. But wait a second. Let me see. Yeah. Yeah, you know what? I think I know. I don't think I know. Um, Angle 1 is supplementary to angle 3. Angle 2 is congruent to angle 3. So then that means that angle 1 is supplementary to angle 2. Sorry about that, boys. Because of substitution. Because I could just substitute the 2 for the 3 here. That's my bad, and I apologize. No excuse. So then, if these two guys, right, these two are supplementary, what do I know about RA and TP? They're parallel. Why? No, not same side alt. No. If same side interior angles are supplementary, then you have parallel lines. Or you could say converse of same side interior angles theorem. And then if these two are parallel, guess what? Trap is a trapezoid. Why? Definition of a trapezoid. Does that make sense, gentlemen? I'm going to take that as a yes. Are there any questions, gentlemen? Anything? Yes, sir, my brother. No, you do not have to prove the other sides are not parallel, because by definition, a trapezoid is a four-sided figure where exactly one pair of opposite sides are parallel. Does that make sense, my brothers? Thank you very much. Hope you learned a lot, and have a wonderful day.